Hi friends and welcome to my new video. Most AI discussions start with a model. That's usually the wrong starting point. Real AI projects don't fail because of algorithms. They fail because the system around them was never properly designed. In this video, I want to walk through the anatomy of a real AI project beyond the model. So every serious AI project starts with a problem definition, not a dataset and not a model. For example, what decision are we trying to improve? Who will use the output? And who is accountable when the system is wrong? If the problem is vague, the AI will faithfully automate confusion. This is where alignment is either created or lost. Next comes data management, which is where most projects quietly succeed or fail. Data determines what the system can possibly know. The system is not magic, it fully relies on data, and to be more precise, to high-quality data. Data quality actually determines how often it embarrasses you. Moreover, lineage determines whether you can explain decisions later, and labels are assumptions made permanent. Feature engineering is where raw data becomes meaning, and this is where domain knowledge actually lives. Business rules, context, constraints, all of that shows up here. If a model looks intelligent, it's often because the features were. If the features are weak, no model choice will save you. Next is model selection and adaptation. This is the part most people misunderstand. In real projects, you usually don't train models from scratch. It's far too expensive and complex. To this end, you select an existing model, configure it, and adapt it if needed. Fine-tuning is optional. As said earlier, training from zero is rare and expensive. The key idea here is simple. Models are interchangeable components, not sacred artifacts. If replacing a model breaks your system, it automatically means that the architecture is fragile. Evaluation is not just about accuracy. You need to know how the system behaves across user segments, at the edges, under uncertainty, and over time. Testing answers two very practical questions. When this fails, and how does it fail? That's how trust is earned. Then comes deployment and infrastructure. Latency, cost, scaling, hardware are all critical factors. Cloud, on-prem, edge, it doesn't matter. If inference cost isn't measured, it will eventually be felt, usually in production, usually at the worst time. Once the system is live, it starts aging. Data drifts, user behavior changes, models slowly decay. In parallel, monitoring watches for silent failure, which is the most dangerous kind. Feedback loops are how systems improve after launch. This is the difference between a demo and a product. Finally, governance and compliance. This includes access control, auditability, versioned decisions, and security boundaries. This is the layer that turns AI from interesting into enterprise-ready. Especially in regulated environments, this is not optional, it's foundational. So when people ask, which model should we use? That's usually the wrong question. A real AI project is mostly about data, systems, and decisions. The model matters, but it's just one part of a much larger organism. Once you start thinking this way, AI stops feeling magical, and it starts feeling engineerable. That's when real progress happens. Thank you for watching this video. I hope you found the subject as exciting and thought-provoking as I did. If you'd like more insights on AI in data, digital transformation, and other tech trends, be sure to subscribe to my YouTube channel. Take care, and I'll see you next time.